All right, in this video, we're going to talk about how we graph exponential growth functions, and you need to pause and get some of this vocabulary down. But while you do that, I just wanted to say exponential growth functions are functions that grow really quickly all of a sudden. One example that you always hear about this is population growth. You know, as there's more and more people creating kids, and all of a sudden the population gets really big. Okay, so I'll catch up with you in a second. All right, the first thing that we're going to talk about is the most basic form of an exponential growth function, the parent function, y equals b to the x. So this number b is, we call it b because it's the base of the exponent. And for growth, b is going to be greater than 1. We'll talk about decay soon. On this graph, there are always going to be two very important points, 0, 1, and 1b. Those will always be the very first 2 points that we plot before we transform any of these functions. This invisible line right here, this is an asymptote. Okay, every exponential growth function has an asymptote. For the parent function, the x-axis is an asymptote. Another important thing that you should notice for exponential growth is that the graph rises from left to right. Okay. The parent function for exponential growth has a domain of all real numbers and a range of y is strictly greater than 0. All right, so let's see an example here with f of x equals 4 to the x. All right, so we're always going to plot 0, 1, 1b first. So what is b? In this case, the b is 4. So we're going to plot 0, 1, 1, 4. Remember that the x-axis for the parent function is an asymptote, so we can't touch this. And it's going to rise from left to right, so we get real close to the axis and then rise through these 2 points. All right, but past the parent function, we can apply all the transformations just like we have always done to all the other parent functions. All the letters do the exact same things. Just like in all the other parent functions, a is going to either stretch, compress, or reflect the function. And it does that by multiplying the y values. H is still a shift left and right, and be mindful that since it's minus h, it might go the opposite way from what you might think. And then finally, k. K just shifts the graph up or down. Now, an important thing to remember about k is that it will also shift the horizontal asymptote. Another thing, going back to a actually, if we have an a times our b, the first 2 points that we'll plot are no longer 0, 1, 1b, but rather we'll plot 0a, 1ab. Right, because since the a values multiply the y values, these are y values. So let's see some examples of these. All right, so here we have the example y equals negative 2 times 3 to the x plus 1. All right, so let's list out the transformations. This negative 2, that will be reflected and stretched by 2. And then this plus 1 will shift it up 1. That's my k. So if this was just a parent function, we would plot 0, 1, 1b. But because we have this a, we're actually going to plot 0a, 1ab. All right, so those points would be 0, negative 2, 1, negative 6, because this negative 2 times 3 is negative 6. And then we have to see this plus 1, so that's going to add to the y values. Right? It's going to shift everything up 1. So we have the points 0, negative 1, 1, negative 5. All right, so let's graph this. We have 0, negative 1, and 1, negative 5. Usually our horizontal asymptote is on the x-axis, but everything got shifted up 1, so we have our horizontal asymptote at y equals 1, And because it got reflected, this graph is going to go from left to right, and it's going to fall like that. So let's squeeze this a little bit. What's the domain of this function? Well, the domain is still all real numbers because it goes forever left and right. But the range are all the y's less than positive 1. All right, so for our final example, we have y equals 3 to the x plus 1 minus 2. Now, a lot of people make the mistake and say that a equals 3, but that is not true. 3 is our base of our exponent. So it's as if we have 1 times 3 to the x plus 1, which would make a 1, so we get to forget about it. So this function's only transformations are that this plus 1 means that we go left 1 and down 2, which will also shift our asymptote. So if I'm plotting 0a, 1ab, well, a was 1, so 0, 1, and just 1b, right? Because 1 times b, so 1, 3. We're going to shift those left 1. The left 1, that means that we're going to subtract 1 from our x values. So minus 1, minus 1. And the down 2 will subtract 2 from our y values. So we have the points negative 1, negative 1, and 0, 1. All right, so the first thing I want to apply is my horizontal asymptote. It was down 2. So I could say that this has a horizontal asymptote at y equals negative 2. We have the points negative 1, negative 1, and 0, 1. We're going to go from left to right and rise through these points. I kind of missed, but whatever. And let's list the domain and range. The domain is all real numbers, and the range are all the y's greater than negative 2. And that's how we graph exponential growth functions.